So on January 6th, that was today, when making this video, I gave some information about how to understand the relationship between factoring and solving by graphing. So one of the ways of solving an equation that we learned before was by graphing, where if you have, an x squared plus something equals, some other equation, that you'd set this equal to y in Desmos, and this equal to y in Desmos, and you look for the x-intercepts. A second, or you just look for where they cross each other, the intersection between the two graphs. Another way is setting equal to 0, like moving everything to one side and seeing where it crosses the x-axis. So I'm going to really focus in on the second method more than the first method, so we can see what's happening with problems. So for instance, if we were solving x squared minus 4x minus 12 equals 0, we would set y equal to that equation, and we'd see where it crosses the x-axis. I can see that it crossed the x-axis right here at whatever this is. It looks like these are going by 1, so this is 6, and this one over here is at -2. So that means that if I put a 6 in for x, 6 squared minus 4 times 6 minus 12 should equal 0, because that's where it crosses the x-axis. We could double check this real easily and say 6 squared is 36, 4 times 6 is 24, minus 12. 36 minus 12, 24 minus 12 is indeed 0. The same thing would be true if we put a -2 in there. That's what makes them solutions. But how does that help us with factoring? So if the question had been instead, factor x squared minus 4x minus 12, we have a lot of different varieties, a lot of different ways of doing that with boxes and everything else. But what this tells me is that when I have a 0, this is called a 0 of the equation at -2, that it gives me a factor of x plus 2, because x plus 2 equals 0 means that x is equal to -2. So I could go backwards and I can say, since x is equal to 2, that means that x plus 2 is equal to 0. I could do the same thing for the other side and say, since x is equal to 6, if I wanted to get that equal to 0, I could say, subtract 6 from both sides, and this would give me a factor of x minus 6. So x minus 6 gives me the factor for the 0 of 6, and x plus 2 gives me the factor for x equals -2. So it's kind of like working backwards or forwards, depending on how you're thinking about it. Now, we could double check to make sure that if we multiplied those two things together, they would equal up to, they would equal up to x squared minus 4x minus 12. You remember before the break, we were doing these kind of things, and see that this is x squared and this is -12. So far, so good. This is -6 up here and positive 2x over here. 2x minus 6x is indeed -4x. So the factored form of x squared minus 4x minus 12 is x plus 2 times x minus 6. And that's the relationship I was trying to get you to in class today. So the difference between a 0, or sometimes they're called roots, and the factored form. So here's another one, x squared minus 7x plus 12. I know you can probably factor that one by looking for two numbers that multiply up to positive 12 that add up to -3 and 4, or -7. But what we see here is that there's a 0 at 3 and a 0 at 4. Now, of course, if x is equal to 3, that means that if I set this equal to 0, x minus 3 is the factor. So one of the factors is x minus 3. I could do the same thing with 4, and I'd get x minus 4 equals the other one. So the factored form of x squared minus 7x plus 12 is x minus 3, x minus 4. So that's what happens. Let's see. Now on the next one, I'd like you to try it first. So take a moment, pause the video, and see if you can come up with the factored form of x squared plus 5x minus 14. Pause the video and try it on your own first before I do it. Okay, I hope you tried it. This one looks like it's at positive 2, and this one looks like it's at negative 7. Now, if x equals negative 7, and I want this set equal to 0, I'm going to add 7 to both sides, and I'm going to say x plus 7 equals 0. You might not even need to do this way, but I'm showing it that way just to see if, so you have a technique if you need it, or if they get harder. So x equals 2, subtract 2 from both sides, and we get minus 2. So x minus 2 times x plus 7 is equal to x squared plus 5x minus 14. And this is a way of showing that. We could multiply that out and double check it. But notice that x plus 7 gives us, x plus 7 as a factor gives us negative 7 as the 0. X minus 2 as the factor gives us positive 2 as the 0. So the next one, notice that this one is going through in the same exact places. It's going through at positive 2 and negative 7. Now, if we did the same thing with this one, we would get our x plus 7 and x minus 2. But we already know that if we multiply that out, that it would be equal to x squared plus 5x minus 14. All the signs are wrong. So in this one, it goes through those 2 points. So we know those are the zeros. And the factored form is almost really close to this thing, but it's not exactly the same. What we would have to do to make that work is to make it go upside down, putting a negative in front. And in fact, if you think about it, if you multiply through by negative 1, you would get negative x squared minus 5x and plus 14. So the factored form still, I mean, the negative 7 gives us a factor of x plus 7. Positive 2 gives us a factor of x minus 2, but we have to know a little bit more if we want to get the original part factored. So let me see. Then we get into something that's a little tiny bit more complicated, but I think that if I do it the same way that I've done the last couple, it'll make better sense. You want to pause and take a second. You're going to have one of them as a fraction, so be careful how you do it. So pause the video and see if you try it on your own. So I see 2 answers. I see negative 1 and positive 1.5. Now, minus 1 is easy enough to say if x is equal to negative 1, one of the factors has to be x plus 1, doesn't it? Now, you have a couple choices on how you want to do the other one. We could do it in a box and know one of the factors, so getting the other factor wouldn't be too hard. We could try it that way. Or we could do it this way. It'd say x minus 1.5, or x is equal to 1.5. So if I set this equal to 0, it'd be x minus 1.5 is equal to 0. But if we do that, what we're going to find is that it's not going to account for the 2 being in the front of that equation. So to be able to understand how to get rid of that fraction, one technique that we could use is by doubling everything in the equation. So if I multiply everything by 2, what I end up with is 2x, because 2 times x is 2x. 2 times 1.5 is 3, equals 0, because 2 times 0 is still 0. Now that one makes more sense to me, because if you think about how this thing factors, 2x minus 3 times x plus 1, if we did that in a box, we would obviously see that the first terms would multiply up to 2x squared, right? If we did it with an x minus 1.5, x times x would be equal to x squared instead of 2x squared. So let's think about this for another second. We knew that one of the factors was x plus 1. We also know that there's a 2x squared and a minus 3. So if you're uncomfortable doing this business down here, then the other way of getting the other factor, one way is to say, oh, if I know one of the factors, I can get the other one. This has got to be 2x up here because they have to multiply up to 2x squared. 1 times negative 3 makes negative 3. And we could double check to make sure the other 2 add up to the right number. Let's see, negative 3x and positive 2x, since 1 times 2x. And then negative 3 plus 2 makes negative 1, which is what we're supposed to get for the middle term. So x plus 1 is the factor for x equals negative 1, and 2x minus 3 is the factor for 1.5, or 3/2 if you think about it, right? Wouldn't that be the same as 3/2 is the same as 1.5? Well, no surprise here that 3/2 is going to give us 2x minus 3. If you need even more verification, try it like this and say 2x minus 3 equals 0. If you add 3 to both sides and divide by 2, you'd get x equals 3/2, which is the same as 1.5. Sorry if that's a little bit confusing, but I'm not sure a better way of explaining it. So try this one. Pause and try this one. One of them will be a fraction. Or, yeah, I think one of them will be a fraction. So that one's -4. Maybe we should do it this way and say, if I know that one of the factors is x plus 4, maybe we can get the other one by seeing what's happening, because I can't exactly tell where that is. I know it's a little less than 2, but it's more than 1.5. So maybe it's smarter to try it out in a box and see if we can find the missing factor. We know this is 3x squared, and one of the factors is x plus 4. Let's see if we can fill in the rest of this box. So x times 3x makes 3x squared. 4 times -5 makes -20. And then the middle terms, -5x and 12x. 12x minus 5x is 7x, like it's supposed to be. So that means that the missing factor is 3x minus 5. Well, that tells me if the factor is 3x minus 5, then the 0, if I add 5 and then divide by 3, the missing 0 is 5/3. That would be an exact answer, no rounding necessary, no estimating or anything. 5/3, well, that's 5/3 is a little less than 2, which would be 6/3, and it's more than 1.5, which would be 4.5/3. So this is the factored form of 3x squared plus 7x minus 20. Now, I just want to recap and see what's going on and see if you can recognize when you have zeros and when we have factors, like the assignment that I gave you, 323, I think it is, or whatever it is. So if a 0 is 1, if that's the place where it crosses the x-axis, the factor related to that, is x minus 1. Because 1 minus 1 is 0. If it's 2, then it'd be x minus 2. These are kind of obvious. But if I have a -1, it has to change the sign, x plus 3, for a -3. And if it's -10, it would be x plus 10. Those are simple enough, I think. Just making sure that you understand the relationship. Now, when they became fractions, they became a little bit harder, but it did the same type of thing. So for instance, if I had and by the way, if I had a factor, you should be able to go back and forth. If I say, the factor is x minus 5, I'd want you to know that the 0 is equal to 5. So when you get into the ones that are fractional, if I have 2x minus 7, if you solve that for 0, you'd get 7/2. You can write it as an improper fraction. It's actually a lot easier because you'd add 7, like 2x minus 7 equals 0, because it's the factors. If you set the factor equal to 0, you can find out what the x value is. Add 7, divide by 2, you get 7/2. If it's 3x plus 8, you'd subtract 8 and divide by 3. If it's 4x minus 9, you'd add 9 and divide by 4. And going backwards is almost the same thing, but let me clear a little space for that. If I give you and I think this is the hardest part, is if you're given the 0 as a fraction, then can you figure out what the factor is? All right. So for instance, if I gave if the 0 is negative something we haven't had yet, -3/4, whatever it is. So if x is equal to -3/4, how do we make that into a nice, pretty factor without any fractions? Because we don't really want to have to deal with the fractions. So I would suggest the first thing to do to get rid of the fraction is to multiply by 4. Multiplying by 4 on both sides we get 4x is equal to negative 3. This is probably easier to do it this way. Then when you add 3 to both sides, you get 4x plus 3 equals 0. So 4x plus 3. Now, some of you might be able to do that in your head, but just to know, 4x plus 3 translates to a 0 of negative 3/4. Let's try another one. I'm just going to erase the whole mess. If you have a 0 of negative 2/11, what's the factor for that one? Try it on your own first. You can pause the video. So if I had x equals negative 2/11, first thing I'd want to do is get rid of that fraction. Multiply both sides by 11. So I end up with 11x equals negative 2. Adding 2 to both sides, 11x plus 2 equals 0. So if we have a 0 of negative 2/11, that comes from a factor of 11x plus 2. Notice that the signs of these things are always going to be different because one's a factor and one's a 0. Negative 2/11 times 11 plus 2 is equal to 0. So it has to be the opposite sign. Let's try one more, or you can pause if you're done. I won't feel bad about it. All right, so how about positive 3/20? If positive 3/20 is the 0, what's the root, or what's the factor? Well, x is equal to 3/20. Multiply both sides by 20, or you can do cross products if you'd rather do it that way. All right, so 20x is equal to 3, and then we subtract 3 to get 20x minus 3 equals 0. So this is how you go between factors and roots. It's certainly a lot easier when you just have a whole number like 8, so you know it's just x minus 8. But if you have a fraction, this is one way of dealing with it. So I'm trying to create the relationship between factoring and solving by graphing. If you can get one of the factors, it makes it a whole lot easier to get the other. But there's lots of techniques, and I hope that you see the relationship between the two things.